Okay, here's the notes on the factor theorem, continuing on the factor theorem. And again, let's just remind ourselves what the factor theorem is, or what it claims, or what's going on. With numbers, let me tell you that there's a number that is about 35,139. There is a number, take your calculators out, you're going to have to do a little calculating, little number crunching here. There is a product, and the product, when you multiply, right, product is multiplication. When you multiply, the answer is this, 35,139, yeah? Well, I'm going to tell you, ready, that there's three factors. There's three factors. Well, when we're talking about factors, we understand that these are the three parts that multiply to give us this one. We understand that, yes? Okay. And I'm going to tell you one of them, yeah? I'm going to tell you one of them is 17. Go ahead and find the other two. What would you need to do to find out the other two? Well, if 17 is a factor of this big number here, wouldn't you divide? Isn't that the key thing here, right? We understand factors divide in, and I know the remainder is going to be 0. That's how I know I'm doing it right. So if I divide by this first factor, does everybody agree? I'm not going to do it like this, but I'm going to use my calculator, right? Because we have technology to assist us with this arithmetic. Did anybody get the answer when 35,139 is divided by 17? What is it, Frank? 2,067, like this? All right. Whew. We brought it down from a 35,000 to a 2,000. Okay. Okay, what are the other two factors? How are you going to find the other two? You can't, right? You'll be here like just trying to guesstimate and what is it called, trial and error and stuff. You're not. So what's going to happen is they're going to tell you, okay, there's a polynomial, there's a number, and they're going to give you one of its factors, but that's not going to be enough. See, because just with one, I'm still stuck. I don't know what are the other two that multiply to give me this, right? We don't know that. So they're going to actually give you two. They're going to give you two factors. So let's start this again. So 35,139 is the product of three. It has three factors. Okay, I understand that. But they're going to give you two of them. What if they tell you that 35,139 is the product of, what happened to my thing? Oh, 17 times 39, and your job is to find this last one, or whatever remaining ones there are. How would you do this? Who can tell me how to do this? Well, we're going to divide by the first one. Divide the 35,139 by the 17, which we just did a little while ago. Yeah? Divide by the first one. And we got, what was it, 2,067? And then what? Do I now divide this by 39? No. If you do 35,139 divided by 39, it's going to give you, I don't know what it's going to give you. 35,139 divided by 39. It's going to give you just another big number that you're still going to be like, well, I don't know what the last factor is. So what you're going to do is you're going to divide by the first one, and we got this 2067, and then get this 2067 and divide it by what? Divided by the other factor, right? Don't divide the second factor to this big one already. We just divided this big number by 17, broke it down. And now since this one is also a factor, then divide this by the next one, 39. You guys understand? Does that make sense? And you're going to get what? 53. That's your last factor. That's your last factor. So it should be true that 35,139 is the product of 17 times 39 times what? We just found our last factor is what? 53. Does that make sense? Let's see if that's true. 17 times 39 times 53. Oh, there it is. 35,139. Yeah. So the point is, they're going to give you a polynomial. In this case, it was a number. And they're going to give you one of its factors. Okay, yes, divide by that factor. And then this answer that you get, then divide that one, by the next factor. Don't go to the second factor and it's like starting over. It's like starting from the beginning. Don't do that. Don't divide 39 into this big one. We already broke it down. It's smaller. Does that make sense? And then divide that by the next factor. Yeah? All right. Okay, so then we're ready to go. Other than that, you should be able to handle this. Okay, here it goes. All right. So here's an example, number 1. Go ahead and write this function f of x. Here's this polynomial, 2x4. Oh, what does 2x4 mean, guys? What does 2x to the 4 mean? That means that how many possible parentheses are you going to have? 4. 4, yeah, yesterday was 3. Plus 7x cubed minus 4x squared minus 27x, damn, minus 18. Woo! This polynomial is to the power of 4. Right there, that tells me that this should have how many parentheses? Damn, 4 of them. 4 factors. You should know that already. Okay, I understand that. But the problem's going to give you, bless you, the problem's going to give you, or is going to tell you that they're going to give you 2 of them. They're going to tell you that x plus 3 and x minus 2 are factors. Go ahead, let's see how you do it. I'll give you a couple minutes. Okay, so this is x to the power of 4. When I divide, which you're supposed to divide by the first one, you're going to divide by the first one. That's going to break it down to x to the power of 3. Then you're going to divide that by the second one. And when you divide that by the second one, it'll break it down and you'll have a polynomial which is quadratic, x squared. Once you get to quadratic, you should be all over it. You should be able to, it's going to be factorable. You'll be able to find the last 2 factors. So first we're going to divide by, what is the first thing we're going to do? Divide by what? The first factor, or one of the factors. I don't care which one you do. Let's divide this first by x plus 3, yeah? How do you divide this polynomial by one of its factors, x plus 3? You got it, Mark? Okay, well, we'll check it right now. We're going to do this one first. Well, can I do a synthetic division real quick? Yeah, synthetic division, so that's going to be negative 3 because it's plus 3, so the 0 is negative 3. And that's going to be 2 for the x4, 7 for the x3, negative 4 for the x squared, negative 27 for the x, negative 18. Woohoo! Does everybody agree that I should have a remainder 0 because it claimed to be a factor? That's how I know I'm doing it right. When I divide by the first one into this, I'm trying to break it down from a x to the power of 4. And when I divide it by this first one, it'll break it down to x cubed. I know the remainder has to be 0. That's how you know you're on the right track and you're doing it right. So when I divide by the first factor, I'm going to get 2 and negative 6 and positive 1 and negative 3 and negative 7 and positive 21 and negative 6 and positive 18. Damn good. I'm good. I know it's good because the remainder is 0. Isn't that a checkpoint right there? That it's a factor, the remainder should be 0? Yeah. So first you divide by the first one of them. I don't care which one. So I already used this one. And now I divided it, and now I'm kind of breaking this down to a lesser degree of a polynomial. Now it's not x4 anymore. Does everybody agree this is x cubed and then x squared and then x, like that? Yeah. So now I got 2x cubed plus 1x squared minus 7x minus 6. So now I get this. Now I divide this one. Now divide that one by the next factor, right? Divided by the next factor. So part 2 is divide. Next what? Divide this by the what? Other factor? The other given factor, right? Does that make sense? What's the other given factor? X minus 2? They give you 2 of them, didn't they? Now divided by the next one, the x minus 2. How do I divide this polynomial by x minus 2? Well, synthetic division. So if that's x minus 2, I'm going to use a positive 2 right there, right? The opposite. And now I look at these numbers here, and that should be the ones that I'm going to put up here. And again, I know that if I'm doing this right, because it is a factor, I know that I have to get remainder 0. It's a factor. We understand that when we divide by a factor, the remainder is 0, right? And then we go ahead and we do that. Easy math that we've been learning now. So 2, 4, 5, 10, 3, 6. Damn good. I am good. Oh, this one's a little tough. Okay, so anyways, when I divided this, which is x to the power of 3, now this one, does everybody agree, is going to be what? X squared and x. Right, so I'm left with a quadratic. And I didn't want you to have this kind of quadratic yet, but oh well, we just ran into it. Usually you're going to have a simple one where you'll be able to factor it out. But once you get it to a quadratic, you know that you have to find the right combination of numbers to get me this. Anybody get it? Mark, what you get? 2x and x, right?
Yeah, that's 2x plus 3 and x plus 1.
So the plus 3 has to be here. You got it?
Yeah, with the 2x.
2x plus 3 and x plus 1 works. Yeah. And you sure that when you add it, it gives you the 5? Yeah, this is actually correct. You guys should be able to handle one like that. But the point is you divide. It's x to the power of 4. You divide it by the first factor. It breaks it down to x to the 3. You divide it by the next factor. It breaks it down to x squared. Does that make sense? So I finally found the last 2 missing factors, right? Remember, 2 of them were given. So let's write this in factored form. F of x is equal to the factored form was, or is, x plus 3, the first one that they gave you, x minus 2, the second one that they give you, and then these last 2 that we just found, yeah, is what? 2x plus 3 and x plus 1. You guys agree? Great. That's part 1. Part 1 is to write this write this in factored form. I can see the factors. Who can take a wild guess of what's the second thing I'm going to ask you? To multiply? Can somebody tell me why I'm not going to tell you to multiply? Why am I not going to ask you to multiply this? If I multiply this, isn't it already right here? Yeah, I'm not going to ask you to multiply it. If I multiply it, we already know what it is. No, I'm not going to ask you that, but I for the other problem I did, but not this one. What is the other thing I'm going to ask you? The zeros. Oh my God. If you have this in factored form and you can't give me the zeros, I'm going to fail you. I don't care what grade you have. I'll change all your points. I'm kidding. All right. What are the zeros? For this one is -3, right? The opposite. That's for this one. What's this one? +2. Psh, easy stuff. And, I don't know if you're going to get that one, but I know what this last one is. It's -1. Who can tell? Don't tell me you don't know how to get this one. No. I don't want decimals. -3/2. How do we do that, Mario? Remember, if a factor is a 0, you set it equal to 0. 2x plus 3, set it equal to 0 and solve it. Is that going to give you -3/2? Yeah. It's also -1.5. I'm not saying it isn't. I'm just saying you should be able to set this equal to 0 and give me the 0. Okay? All right, let's do another one real quick, super quick. Ready? Example 2. I don't have to talk and explain and guide you to the problem. We're just going to do it quick like. Okay. F of x is equal to x4 minus 6x cubed plus 7x squared plus 6x minus 8. And the given factors, I'm going to give you two other factors. Are x minus 1 and x minus 2. So the question or the task, the objective is going to be write this in factored form and then find all the zeros. Yeah? All right, so first we're going to divide by the first factor. And that is going to be the x minus 1. Okay, so that means I'm going to do synthetic division with a positive 1, 1, negative 6, positive 7, 6, negative 8. I know it's a factor, so a good checkpoint is I know it's going to give me remainder 0. Okay, anybody get that already? Got remainder 0? Okay, so you should have this 1, 1, negative 5, negative 5, 2, 3. Oh, what? I messed up. 1 times 2, I put 3. Stupid Aviles. 2. 8, 8. Okay, 8. Whew, okay, see, I would have not got a 0 if I did that mistake. What does that mean when I divided by the first factor? That means that this one went from x4 to now what? X cubed minus 5x squared plus 2x plus 8. We're good? What do I do next? I already used this one. Now we're going to divide this one that we just found by the next factor, by the other given factor. Okay, we're breaking it down more. And that's what's the other one? X minus 2, yeah. So now that means that we're going to have positive 2, and that's going to be 1, negative 5, right, this one here. 1, negative 5, 2, 8, and I know I should get remainder 0. I know I'm on the right track because they're factors. It was telling you that they're factors. So, damn, I'm good. It worked. It's good, it's working, everything's making sense. Okay. And then now you went from x to the power of 3 to what? To this. Everybody agree that these numbers here are going to be what? X squared x, like that? And that's what you want. You want to eventually get it down to x squared. Go ahead, Mark. Because then this part that's quadratic is factorable, and you'll find the last two factors. This one's easier, yeah? That's going to be x minus 4, x plus 1. Find the last two factors. All right, so write this polynomial in factored form. Well, these are the last two that I just found. And the first two that were given were that's it? No, that's not it. Make sure you also give me the zeros. If you got the factors, you should be able to give me the zeros. Positive 1, positive 2, positive 4, negative 1. Easy money. Easy. We got it? Easy final. Okay. Make sure you understand all of it.